First one, this is a part that we need our users to provide to us when they ask us for support. They need those kind of software versions because there are some a lot of problems are caused by the controller versions or some other versions not matching together. Okay, so what we need to do is to go to settings, basic, and specification. We can know the models in here. We can know the controller version here, 3.5.2.8. We can know the algorithm version here, system version here, and those different versions of the server, C file, feedback, something like that. We need those versions so to help us to locate the issue. Okay, so with those necessary information, we will be more efficiently to help you to provide our support, our suggestions, our solution to your question. So this is necessary when you need to ask us for help. And this one, users can drag a single joint of the robot by unlocking the joint when the device is not enabled. So this is very important. When the robot, when there's a condition that the robot is not moving and you need to move the robot by the joints, what we need to do is to unlock the brake. Unlock the brake. How do we do it? We go to the settings, find the security setting, and we find the braking here. So you can see we have the 6 brakes for 6 axes. You can just press here just to open the locks. The most important thing is that make sure there's someone by the robot holding it, just in case it falls down when the brakes are unlocked. This is usually used to drag the machine to the apart position through the joints locking. When the robot is enabled in a narrow environment, that may cause hitting of the nearby objects. So please make sure that there's someone nearby, there's someone holding the robot arm, and make sure that the robot will not move in a fast way. Also, you need to make sure that the robot is not enabled, is in disabled mode. And make sure that someone is near the robot holding it, just in case it falls down by the gravity. And now is the terminal load. You can see this is the TCP we are talking about. This is the end flange. This is the flange of the cell robots. You can see here. So the top center of mass offset in CX in X direction, offset C1 in Y direction, CZ in Z direction. The unit is MM. So this is the default TCP center. This is it. This is the, you can see here is the buckle here. This is for the inter communicating. And this direction, this up down, this up to the up. This way is X and this is Y. And here, this direction is Z. Okay. So this is the offsite payload diagram for each model. So for CS3 here, what does this diagram use to? You can see here, for CS3, we all know that the payload is 3 kg. It's interesting that we name out the models with the payload of each one. CS3, 3 kg, CS5, 5 kg, and CS16, 16 kilograms. So this number means the payload it can hold. So for CS3, it's 3 kg. But what do we need this diagram? You know, if we put something right in here, the payload can be 3 kilograms without any problem. But if the inter or the loss is too large, for example, if let me use a pen to draw it. So if I use a pen, if I use some tool like this, which is in a eccentric direction. For example, I'd like to add some tool in here. And the payload is in here. In this way, there's an offset in the Z direction for like 25 centimeters, and for the XY direction, it should be about 10 centigrams here. So in this way, I will be checking this diagram, and this is the payload that the CR3 now can do with this kind of essential, which is 1 kilograms, which means if I use a tool like this, the payload would be different. It would be less than 3 kilograms. The tool is in here, and the payload will be less than 3 kg. It turns to 1 kg. So if you want to calculate the payload of your object, you must measure the offset in each direction of your endpoints. And it's all the same for the rest of them. Cell 5, also I will draw another one. For example, if your grapper or something is like this long, and in this way, you want to pick up something in this direction with offset in XY in like 18 centimeter and Z 25 centimeter. The payload of your robot will decrease into 2 kilograms in here. That's where you should check. Okay. So those diagrams for different models is for your reference when you want to do something very offset to the TCP points. You need to use this diagram to calculate how much value, how much load you can put on the end arm. And this is CR10 as well. For this range, is 10 kilograms without any problem. This one, this one, 8. And for this one, 6. So the longer the tool you have, the less value, the less payload you can hold with your CR robots. It's all the same for 16. Just that the offset is much longer and than the others. Okay, once we have settled the offset in XYZ directions, we will use those parameters to tap in when enable the robot. We need to enter the offset in each direction here when you enable it, and we will input the value into it, and so the robot will calculate by itself to see how much force it should output. And here, we just mentioned that we can use the buttons to make the robot into teach mode. And if you have trouble, you find it very difficult to drag. If you have you have done something like this, you can change the sensitivity of each joints to make it much smoother or much harder to move. You can change it here in the settings to change the sensitivity of each joints. All right. In addition to the conventional installation, CR robots also support left and side installation. And the rotation angle and the installation angle need to be set with different installation methods. And you can choose one here. You can choose the right direction you want to install. Users can get installed in rotation angle and tilt angle through the interface collaboration function. Adjust the robot position by inching and making the terminal flange face up and particularly to the ground. Then click collaboration button. And during the conventional installation of the machine, the rotation angle and the installation angle are both set to 0. Otherwise, there will be error doing it. Do not modify it. Another thing is that we can change the IP of the line port of the controller by in the settings of the software. Only the IP address of LAN 2. Notice that there are 2 LAN ports for the MT400. And the only LAN 2 can be modified, and you can choose your own IP address in here. The default one would be 192.168.51 by the cable for cell robots, and 1.6 by Wi-Fi. So when you change the IP address, these two are reserved ID IP addresses, and you cannot use them. Other than those 2, you can use them to change your modified IP. Also, each CR robot comes with a Wi-Fi module, which is a Wi-Fi adapter, and the default name of the Wi-Fi would be the SN number of the robot. And you can also change the Wi-Fi's name and password in the settings here. You can change to anything you like here. But usually we don't suggest our users to change it, because in default there will be the SN, so that you can know which is the model, which is the robot you are connecting to. Okay, so that's it. So here is the some alarm introduction that we like to introduce you. You might be encountered during your usage. So we have this positive limit alarm. It means when the joint jogging exceeds the set range, and the limit alarm will be reported. What we need to do is to jog the joints towards the opposite direction, and then the problem will be solved. For example, we have this positive limit of joint 6. What we need to do, like this, we need to, it's reaching 360 degrees. What we need to do is press minus, so that this value can go to the negative direction, so that the positive limit will be cleared. It's all the same for the other negative limit alarm. Another thing is that, which is common for the collaborative robot, is the singularity alarm. So you can see that we have different types of singularity grams. The joint, the TCP of the robot is located in the plane, which is composed of G1 axis and G2 axis, which will lead to the singularity. Singular position of elbow joint is when the bottom and the forearm of the robot are in a straight line. It will lead to it. And also we have this west joint singularity position. When J4 and J6 axis of the robot are in the parallels, it will result in the singularity. We have some photos for you that you can check for reference. This is the shoulder singularity point. You can see the TCP here, is located in the plan performed by the joint 1 and joint 2. We have joint 1 here, joint 2 here. Those two joints, those two lines, center of joint 1 and center of joint 2 makes up a plan, and the center TCP is located in this plan. This is a singularity point, which is called shoulder singularity. And second one is elbow singularity, which means the rear arm and the forearm are in the straight line. This is a forearm, this is the rear arm, and now you can see they are in a straight line. This is the elbow singularity. The last one is the rest singularity. You can say that joint 6 and joint 4. So the center line of two joints are alleged they are parallel to each other. This is also the rest singularity. So for these three different conditions is what we should avoid. This will cause the singularity alarm, and the robot will behave in an unexpected way. So this is what we should do. What we should do to avoid this. We need to, when the error happens, we need to choose some other points to avoid this posture happen. And this is a API parameter error. When the API is programmed incorrectly in the script, this kind of error will appear. This is called controller error, and the Go command has no input parameters. You need to go back to check your scripts to see if there's some parameter missing or some other contents missing. And here, alarming. When the script is run, the parent window will also promote the specific location of that error, which is commanded for us to target the error. You can see here we have this alarming here. Attempts to call a nil value in here. This one we will guide you to locate the issue. Okay, this is the 4 content of our training today. And if you have any question, feel free to ask us here. You can type in the chat box here, or you can just send email to us, or you can just send a voice to us. Okay.